I have been managing a number of different vegetable gardens for quite a few years now, generally starting with the same soil type and fertility levels that would have been available in this former pasture. But because each of these gardens has been managed in a different way since then, I would expect differences to appear in the quality of the soil and in the fertility levels. Over the years, I've noticed definite differences in how well the plants grew in the different gardens, how healthy they looked, as well as occasional deficiencies in the leaves. I've also noticed significant differences in the taste of the same crop grown in the soils managed in different ways, and I've measured significant differences in yield. All of this helps me to better understand what might be happening in the soil underground, but a lot of it is guesswork and assumptions without the availability of more detailed information. So this year I decided to take soil tests of all the different gardens that I'm managing in order to better understand how the soil fertility may have changed. I have tested the soil in these gardens at different times in the past, but this was the first time I collected soil samples from all 7 different growing spaces at the same time and sent them to the lab for detailed analysis. I asked the lab to use a particular test with a high pH solvent, which is supposed to be more appropriate for the calcareous soil that I have, as it apparently gives a more accurate reading of the levels of nutrients that would be available to the plants. Each test includes the pH, which is in the high or alkaline range of 7.6 to 7.9, which is what I would expect with the naturally abundant levels of calcium in this limestone-based soil. The tests also include the percent of organic matter in the soil and a calculation of the TCEC, or the total cation exchange capacity of the soil. A key component of these tests are the quantities of the main cations of calcium, magnesium, potassium, and sodium, as well as the relative proportion of each of these compared to the total amount of cations that the soil can hold. The tests also include the amounts of the main negatively charged elements of phosphorus and sulfur, and 6 essential trace elements: boron, iron, manganese, copper, zinc, and aluminium. So I now have information about the levels of 12 essential plant nutrients in the soil of each of the gardens, but unfortunately the tests don't include nitrogen, as apparently it is too volatile and harder to test accurately in this way. Most people grow on acidic soils and would keep an eye on the pH levels of their soil, but I'm not so interested because I know that there's plenty of calcium there, and there's also not much I can do to bring down the pH level apart from perhaps adding excessive amounts of sulfur to the soil. The percentage of organic matter, on the other hand, is really quite interesting to me, as it's a useful indication of how well developed the soil is, with the general idea that the more organic matter there is, the better. Apparently, it roughly represents the potential levels of biological activity in the soil, which is also good for the plants, as well as being a rough indication of the amount of nitrogen that could be available to the plants as this organic matter decomposes. The lowest level of organic matter was 7.5%, found in the soil of the relatively new Black Tunnel, and this is disappointing as last year I had grown a green manure crop specifically to increase the amount of soil organic matter in this garden. I'm not sure what happened, but the levels actually dropped compared to the test I had done before growing the green manure, and as a result I've decided to buy in extra compost for this garden this season in order to boost the levels of organic matter in the soil. The simple garden had only 9% organic matter, but I'm not so surprised as this is a relatively new growing space, and I haven't added compost to this section I tested for almost 2 years. The extensive and intensive gardens had roughly the same levels, which is a bit surprising, as I typically add twice the amount of compost to the intensive garden compared to the extensive garden, and again, I'm not sure what is going on here. The polyculture garden was a bit higher at 11%, probably due to the biochar I've been adding, though I'm not sure how this would show up in the tests. The polytunnel garden has more than 12% organic matter, which is a good indication of how well developed the soil in this intensive growing space has become over the years. The highest level of organic matter was found in the no-dig garden, with over 16%, and this is to be expected as I had added a 5 centimeter or 2 inch thick layer of carbon-rich compost to the surface of this garden at the beginning of last year. The TCEC calculated for each of the gardens varies from 11 to 14, and it roughly correlates to the differences in the levels of organic matter. In the extensive, intensive, polyculture, and polytunnel gardens, the calculated levels of TCEC is slightly higher than the organic matter percentage and are more or less proportional. In the less developed simple garden, the TCEC was proportionately higher than the amount of organic matter, and the black tunnel was even more out of proportion. I wonder if the TCEC in both of these gardens will increase proportionately as the levels of organic matter increases. With the no-dig garden, the opposite has been found, with the relative proportion of the organic matter being significantly higher than the TCEC. And this is no doubt due to the huge amount of compost that I added, which had contained a fair amount of partially decomposed high carbon or woody material. I imagine that this will have been included as part of the organic matter percentage, but has not decomposed enough to be able to hold on to fertility in the soil in the way that it would increase the TCEC. It will be interesting to see what happens in the next few years as this organic matter further decomposes and more is added, and if the nutrient holding capacity of this garden can increase to match or surpass the high levels of the polytunnel garden. Looking at the breakdown of the base saturation percentage, or the proportion of the total amount of negatively charged nutrients that the soil can hold, calcium takes up between 79 and 88% within the different gardens, which is really high and apparently typical of calcareous soils. This does not leave a lot of space for the other nutrients that can be held in the soil in the same way, including magnesium, potassium, sodium, and the other trace elements. Comparing a typical sample from my gardens to what is the conventional recommendations from the lab, there is obvious differences in the proportions and a complete lack of any exchangeable hydrogen. Changing my soils to better conform to this recommended proportion would probably be quite disruptive to the soil life, and given that I've already been able to grow great quality vegetables in this very alkaline soil, it doesn't seem worth it to me. And this is the advice that Steve Solomon and Erica Reinheimer give about balancing the minerals in a calcareous soil, to accept that the soil is always going to have a high pH and work within that. And their recommended proportions are much closer to what I have in my soils, which makes it an easier target to aim for. Looking at the proportions of the individual nutrients that make up this cation exchange capacity, there is significant variations between the 7 gardens. The proportion of calcium in 5 of the gardens is not too far off the 85% target recommended by Steve and Erica, but the soil in the polytunnel garden is lower at 80%, and I think this is probably due to the small amounts of sulfur that I've been adding regularly to the soil in this garden. The sulfur apparently shifts the calcium out of the way, allowing space for the other nutrients. The levels of calcium found in the no-dig garden is even lower at 79%, and this is most likely because the sample that I collected from this garden was partially soil and partially the remains of the compost on the surface of the soil. There is also a wide variation in the levels of magnesium found in the samples, with the polytunnel and no-dig gardens being the highest, likely because of the lower amounts of calcium, but all of the other gardens are also above the recommended targets, so this nutrient is not something that I'm concerned about. The levels of potassium are even more varied, with 4 of the gardens having levels quite a bit below target. The intensive and polytunnel gardens are close to the target, and the no-dig garden has almost double that amount. This makes sense as the levels of potassium would likely be related to the amount of compost that has been added, and these 3 gardens have had the most compost added over the years. The levels of sodium for all of the gardens is between 0.5% and 1%, which is apparently fine. And all of the other nutrients calculated in this section, including the trace elements, take up a bit less than 4%, which is apparently typical. For the sulfur and phosphorus, which are the 2 main anions or negatively charged nutrients that were tested, there isn't any recommendations from the lab. But Steve and Erica recommend a target level of phosphorus that is equal to the target of potassium for each of the gardens, and 35 parts per million as a target for sulfur. The levels of phosphorus in the extensive and intensive garden are very close to their targets, and the no-dig garden is higher than the target, again likely due to the abundant amount of compost. In the polytunnel garden, the levels of available phosphorus is quite a bit above the target, probably due to the soft rock phosphate that I've been adding over the years, but there could be other factors involved. The other 3 gardens all have levels lower than the target, and it would be good to find ways to increase the availability of this essential nutrient. The levels of sulfur in 5 of the outside gardens are all similarly low, with less than 1/3 of the target available, whereas the soil in the 2 polytunnels are quite a bit higher. I wonder if this is at least partially due to the excessive amounts of rain that we've had in the month before the soils tests were taken, which may have washed out the available sulfur from the soils in these gardens, but not from under the cover of the plastic. And I suspect that the higher levels of sulfur found in the polytunnel garden may be a big reason why the nutrient balances in this soil is so different from the others. And I'm beginning to think that it might be a good idea to regularly add small amounts of sulfur to the soil of the other gardens. Of the 6 trace elements that were tested, the levels of iron and manganese are both at least double the recommended target, so nothing to worry about, and the aluminium also seemed to be fine. The levels of boron are typically low in this soil, even though only a tiny amount of this essential nutrient is needed, but these levels can be boosted if desired by adding tiny amounts of borax. The levels of copper in 5 of the gardens are all surprisingly similar and about 60% of the target, but the levels in the extensive and the polytunnel gardens are much closer to the target. This is most likely due to the small amounts of copper sulfate that I have been adding to these 2 gardens over the years. The levels of zinc are all low, with the less developed soils having lower levels than the others, and this is something to perhaps amend with careful application of zinc sulfate. Looking at the individual gardens, it's interesting to see how they've diverged from each other, and where deficiencies may be causing issues. The extensive garden has adequate levels of most nutrients, but the levels of potassium and sulfur definitely need to be improved, and some of the trace elements are a bit low as well. I'm quite pleased with the balance of the main nutrients in the intensive garden, and the levels of the no-dig garden significantly exceed the targets. The exception in both cases are the levels of sulfur, and I wonder how much better both of these gardens would produce if I added sulfur as an amendment. The polyculture garden could definitely use more phosphorus and potassium, as well as sulfur, which is perhaps why this garden didn't do so well last year, and the simple garden and the black tunnel have similar deficiencies. I suspect that the same deficiencies would be found in all of the soil of this site. With some of the gardens, I plan to carefully add concentrated amendments to boost the levels of boron, copper, and zinc. But with the polyculture, intensive, and no-dig gardens, I plan to wait to see what impact the additions of compost and biochar will have. The polytunnel garden has the most balanced soil minerals, according to these soil tests at least, which is good to see, as it is the garden that I've put in the most effort to remineralize over the years. I think this mineral balance is one of the main reasons that I've had wonderfully abundant, healthy, and tasty crops out of this garden, and I think it serves as a useful example of the possibilities of soil testing and of careful remineralization of the soil over a number of seasons. This soil testing is part of the process of seeking to better understand the benefits and limitations of each of the gardening methods in managing the relatively unusual soil that I have to grow with, and to figure out how I might be able to improve the soil conditions in ways that are appropriate for each of the methods. If I do things well, this will benefit the soil life and the plants that grow in that soil, improve the resilience and productivity of these gardens into the future, as well as benefiting those of us who eat the vegetables.